Let's say I want to take the derivative of x to the x, and I want to find dy dx. The problem is, I don't know if this thing is an exponential or if this thing is some sort of power. I've got a variable to a variable, and I've not really seen anything like that before. So one strategy when you're stuck with these exponents to exponents kind of thing is we can use logarithms. Here's why we might want to do that. By taking the natural log of both sides, or really any log, I can use the power rule for logarithms to drop the exponent. So I can rewrite this as ln of y times x ln of x. So now instead of having this complicated exponential, I now have a product of functions. I can take the derivative of the product of functions using the product rule. So what I should do from here is I should take the derivative of both sides with respect to x. The derivative of ln of y is 1 over y. Since I took the derivative of y with respect to x, I have to pick up a dy dx there. The derivative of, oh, this is a product. So let's use a product rule. We'll have the derivative of the first function times the second plus the first function times the derivative of the second. One over y dy dx. Let's take some derivatives. The derivative of x with respect to x is 1, so I have 1 times ln of x. The derivative of ln of x is 1 over x. One times ln of x is ln of x, and x divided by x is 1. My goal was to get dy dx by itself, but I almost have dy dx by itself already. I just have this 1 over y that I need to deal with. So to get rid of that 1 over y, let's multiply by y. My multiplying by y on the left side, the y and the 1 minus y, 1 over y would cancel out. That leaves me with dy dx. On this other side, I have y times ln of x plus 1. Technically, I have my derivative here, but I could make this look a little bit cleaner because this still has both the letters x and y in my derivative. So just as a final note here, I could take y equals x to the x and say every time I see the letter y, I'm going to plug in an x to the x. So I'm going to replace that with its function. So this tells me my derivative with respect to x of x to the x is x to the x ln of x plus 1. Using natural logs on both sides of an equation allow me to take complicated powers and change them to the product rule. If you find yourself stuck and there are exponents that you don't know what to do with, try taking the log and see what happens. This is called log differentiation, and it's a really great strategy.